the percentage rate of change of f. Rate of change of f is f prime of p. F prime of p. Here we talk about the demand function is a quantity of units demanded is in terms of fp is a function of p. P is the price per unit. Now the rate of the change is f prime of p. Relative rate of change is this is a per dollar quantity change, quantity how much per dollar, that's f prime of p. Per dollar quantity how much quantity per dollar, that's that's the rate of the change of the quantity. Then divided by quantity f, this is x, it's a quantity demanded. This we call relative rate of change. And then change to percentage, which is times by 100%, which is 1. And that is it's equal. This is we call percentage rate of the change. It's equal to relative rate of the change. Equal. They are equal. Now, relative rate of the change of the percentage rate of the change is equal relative rate of the change. So I put f prime of p over f of p divided by percentage rate of the change of p. P is the price. P is the price. So P is the price. This price, you take derivative to the P is just 1. Just like X take derivative to the X. It is 1. Now the variable is P. So take derivative. So for the price P, you take derivative to the P and divide by price P. This we call a relative rate of the change divided, and which is dp is 1 over p. So here, so you got 1 over p. This become relative rate of the change of the price p. P is unit price. And then if you put the percentage 1 over p, you times by 100%, which is still 1 over p, because 100% is 1. And then you can put 100 over p percent. So this we call percentage. So they are equal. So percentage rate of change is equal relative rate of the change. Percentage rate of the change of p is equal relative rate change of p. So the two divided. Then this reciprocal. And so p times on the numerator. So get p times f prime of p over f of p. This 1 over p become p over 1. And times together is p times f prime of p over f of p. Yeah, this one. This is a per percentage rate of the change, which is the price change 1%. Then ask you the demanded change how many percent. So this denominator 1% change, then numerator ask how many percent of the change in the demand. Numerator is demand. F prime of p is demand function. Denominator is price per $1 increase or decrease. Then demand per 1% of increase or decrease on the price. And then the demand is change in increase or decrease. How many demand, how many quantity changed. That's this one, this meaning, and is this formula. So we define called elasticity of demand at price P, defined as E of P, elasticity in terms of price, equal to this number, take negative. Why is it take negative? Because f prime of P is a quantity. Because for the demand function is decrease functions. When the price increased, demand will decreased. When price decreased, it gets cheaper, then you sell out more units, the quantity increased. So it's the opposite. So their slope, f prime of P, is negative. Since this is negative, the P's price is positive. FRP is how many quantity, X. And so this value is negative. And in economics, the economists, they want use positive to evaluate for the elasticity. So we put a negative sign and make this become positive because this is a negative. And put a negative sign, make the elasticity become positive. Now, if the two are, if elasticity demand is equal 1, that means 1% of the price change, and the numerator is 1% of the quantity change. They are equal. Then you divide it, will be equal 1, and we call unitary. Unitary is it's equal. The change is equal. Percentage change are equal. Percentage change in quantity is the same as the percentage change in the price, equal. And that's what we call unitary. If greater than 1, that means the numerator, which is the percentage rate change in quantity, in demand, is greater than the percentage change in price. And we call elastic. The market is elastic. Elastic. If greater than 1. If less than 1, that's what we call inelastic. Means the percentage rate less than 1. So the numerator is smaller than denominator. So divided is less than 1. So that means percentage rate change, which is a demand of the quantity change, is less than the price, percentage on price change. Then we call inelastic. So elastic means is larger, is you can change more, so it's a larger one. And inelastic is a smaller one, so it's slowly changed. That is less than 1. The numerator, the quantity change is smaller than the price change in percentage. Then we call inelastic. If you change the price larger, but your demand is a smaller change, that is the economics is elastic. Inelastic, we call elasticity. So what is the revenue function? Revenue function is in terms of P, is P times X, equal P times X. X is the F of P. This is a revenue function. And what is the R prime of P? Take derivative. So this use product rule. First of all, P take derivative is 1. So 1 times product rule. The second function do not take derivative is F of P. So 1 times F of P plus first function do not take derivative. P do not take derivative is P times second function P, F prime of P take derivative. This use product rule. This product. Two function product, use product rule. Take derivative, get this. Factor out F of P. So F of P divided by F of P got 1. Plus this divided by F of P. So this one divided by F of P. So become F of P times 1. What is this? This one is a negative ERP, elasticity. So this times negative sign, both sides. You got negative this equal this part, which is this part. So this part replaced by negative ERP. So we got 1 minus ERP. Now, if ERP greater than 1, if ERP greater than 1, which is elastic, if ERP greater than 1, which is elastic, and 1 minus this greater than 1, if you do 1 minus subtract 1, become negative, because E is greater than 1, so subtract from 1 is negative, times FRP is quantity, is X, always positive, tying together become negative, then R prime RP is negative, is less than 0, is less than 0, is negative, is negative. R prime RP is negative, that means revenue is rate of revenue is negative, that means the revenue is decrease. So revenue is decrease. So when demand is elastic, ERP is greater than 1, then the revenue, then the change in revenue and the change in unit price move in opposite directions. So when your price is increased, the revenue is decreased, because at prime, your P is the price. If you increase the unit price, then the revenue is negative, is decreased. First derivative is negative, the function is decrease function, so it's in opposite directions. Now, if equals 0, ERP equal 1, then this rate change is 0. That doesn't change. So P price changed, the revenue is still the same. The rate is 0, doesn't change, so it's still keep the same. Now, if the ERP is less than 1, then you subtract 1, is going to be positive. 1 minus ERP is positive, and the FRP is X, is a demand quantity, is always positive. Tying together is positive, so R prime RP is greater than 0. And so in elastic case, then the R prime RP is a positive. That means if the demand is inelastic, then revenue and unit price is the same direction. If the unit price increased, revenue increased. Unit price decreased, revenue also decreased. So let's do question 4. Refer to problem 3. Consider the demand function, demand equation P equals negative 0.03x plus 600. Here, problem 3. This is a problem 3. This is a given. Price in terms of X is this one. That's we in question 3. This one. P price in terms of quantity X. Which describes the relationship between the unit price P in dollars and the quantity demand X of the Rossonic model F loudspeaker system. So find elasticity of the demand E of P. Now, first of all, we write down ERP. ERP is a negative P times F prime RP over FRP. Now, where X is a demand quantity equal in terms of price, FRP. Now, given function is P in terms of X, so we have to change X in terms of P. We have to get X equal in terms of P. So first of all, we change this, because here we have to use FRP. I have to use X in terms of FRP. So we change this function. This is a function in terms of X. Now we are going to change it in terms of P. So we solve for the X. Solve for the x. So here, this p equals negative 0.03x plus 600, which is this one. Then we move this negative to the left side, change to positive, is net 0.03x equal. This p move over, become minus p. 600 minus p. Solve for the x. Divided by 0.03. 0.3 cancel, get x equal 600 divided by 0.03 minus p over 0.03. Now 600 divided by 0.03. Here has 2 zeros, so you add 2 zeros, get 6, and divided by 3, get 2 with 4 zeros, minus 0.03, put fraction is 3 over 100, and divided this 3 over 100, reciprocal, become 100 over 3 times p. And this one is fx equal function in terms of p. F of p, x equal f of p is a function in terms of price, equal to 20,000 minus 100p over 3. Now here, elasticity formula here, we need to figure out f prime of p. And f of p already got is this. And we need to figure out first derivative. So this function take first derivative. So 20,000 take first derivative is 0, minus 100 over 3p take derivative to the p is minus 100 over 3. Subtraction is negative 100 over 3. That's f prime of p. And plug into this, so E of p equal negative p f prime of p over f of p equal negative p still p times f prime of p is negative 100 over 3. What is f of p? F of p is this, 20,000 minus 100p over 3. So the two times together, negative times negative become positive, and 100 over 3 times p is 100p over 3. Then this denominator is 1, and you times by 3 both sides. You got 30,000, denominator is 3, and 30,000 minus 100p. And divided, you reciprocal, then 3 cancel, and you got 100p over 60,000 minus 100p. That's the elasticity function in terms of p. Elasticity function in terms of t. So here want to be elasticity of the demand. E of p is this. Now then compute E of 100. So P is when price is $100, so plug into this 100, plug in. So the 100 times P is 100. 60,000 minus 100 times 100. So it's 10,000 minus 60,000 minus 10,000 is 50,000 divided 40 cancel is 1 over 5 equals 0.2 is less than 1. So when price 100, elasticity is less than 1. Then we interpret your result. Interpret your result. What this means? Means when the price is $100 per Acrosonic Model F loudspeaker system, an increase of percent of unit price, because elasticity of demand is defined by this number times a negative sign. So this number is negative times what this definition is per 1%. Denominator is percentage rate of change of P. That's per 1% change in price. Then numerator is F function is demand quantity. Then demand quantity in how much percent. So here, when it's negative 1, less than negative 1. What's this E of 100 means? Means when when the price is $100 of the speaker per speaker, price is $100, then an increase of 100% of unit price, which is 100%, you increase by 1%, which is increased by $1. $1. The price become $101, increased by $1, will cause a decreased because this number is negative number, and you put a negative sign, so this ERP become positive number. And the economists want to use positive number to represent elasticity, so they're easier to do. So, but actually this number is a negative number, which is 1% increase, which is positive. The numerator should be negative, so it should be decrease of approximately 0.2, 0.2% in the quantity demanded. And this demand elasticity less than 1 is inelastic. The demand is inelastic. Then ask you another one. C. Compute E of 300 and interpret your result. So E of 300 and plug into, we find out E of P is 100P over 60,000 minus 100P. E of P is equal to 100P over 60,000 minus 100P. So plug into this. Plug in. So it's 300 put in P. P is 300. So get 100 times 300 and 60,000 minus 100 times P. P is 300. Figure out. So it's 30,000 minus 60,000 minus 30,000. Get 30,000 over 30,000 equal 1. And what this means when the price is $300 per speaker system, an increase of 1% of unit price will cause a decrease of approximately 1% in the quantity demanded. It's equal. And this demand is unitary. It's equal. They are equal percentage of increase and the decrease. Then next one. Compute E of 500 and interpret your result. So E of 500. So P use 500, plug in. Is plug in this 100 times 500 over 60,000 minus 100 times 500. So get 50,000, 60,000 minus 500, 50,000. So get 50,000 over 10,000. So get 5 greater than 1. Greater than 1 is the demand is elastic. And what this means, interpret your result. Which is when the price is $500 per unit per speaker, a loudspeaker system. An increase of 1% of unit price will cause a decrease of approximately 5% in the quantity demand. Demanded. And the demand is elastic. Then next. If the price is 100, will raising the unit price slightly cause the revenue to increase or decrease? Revenue. Now this time talk about the revenue, R of X. R of x. So first of all, E of 100. We're looking for E of 100. That's what we figure out in here. E in B. E of 100 equals 0.2 is less than 1. The demand is inelastic, less than 1. So here, since E of 100 equals 0.1 is less than 1, the demand is inelastic. Now, when inelastic, the revenue is the same direction as the unit price. Same direction. Here we talk about here. If inelastic, that's ERP is less than 1, the R prime RP, the change in revenue will be positive because ERP is less than 1. E minus ERP is positive, tying together. FRP is quantity, tying together is positive, tying positive is positive. So R prime RP is positive. So it's greater than 0. So it's when price P, that's R prime RP is positive. That means when P is increased, slope is positive. So revenue is increased. So demand, when demand is inelastic, the revenue and the unit price change in the same direction. So when E of 100 equals 0.2 less than 1, the demand is inelastic. Unit price at $100, in $100, raising the unit price slightly will cause the revenue to increase. Because the unit price increased, the revenue raising means increased unit price. Then the revenue is also increased. Then ask you, if the price is $500, will raising the unit price slightly cause the revenue to increase or decrease? So E of 500 is equal 5. And that's we just figure out over here. In D, E of 500 equal 5, greater than 1. The demand is elastic. In elastic, then the unit price move and the revenue, they are move. Unit price and the revenue move in opposite direction. So in elastic, ERP is greater than 1. Then this 1 minus ERP is negative. Negative times positive. So R prime RP is negative. Negative means decrease. R is decreased when P is increased. So demand is elastic. Then the revenue and the unit price, they moved in opposite direction. So that means when unit price is $500, in raising the unit price slightly, which is increased, then the revenue is decreased, will cause the revenue to decrease. So that's next one is a higher section 3.5. Section 5, higher order derivative applications. So the revenue rate of the change of function f at x per unit change in x is f prime of x over f of x. This is the relative rate of the change of function f. Rate of the change of function f is f prime of x. You divide it by f of x, we call relative rate of the change of f at x unit price change in x is f prime of x over f of x. And you change to percentage, you times by 100%, which is still equal. And this term we call percentage rate of the change of f at x. This one, second, this one, they are equal. This we call relative rate change. And this we call percentage rate of the change. So next, inflation rate of economy is the same as annual percentage rate of inflation in CPI, Consumer Percentage Index. So it is I prime of t over I of t, which is relative rate change. This is the relative rate of the change equal percentage rate of the change. Here should be t, it's not x, t. T is in time, how many years. So now next we are going to give one example. This example say, number 5, an economy's consumer price index, CPI. Consumer price index, CPI, is described by this function, I of t. T is in years. T is measured in years. T equals 0, corresponding to the beginning of 2006. So this function, I of t, is CPI, consumer price index, CPI, in terms of t. T is years. So A, find the annual percentage rate of inflation in the CPI. We call annual percentage rate of inflation in the CPI. Briefly say is inflation rate. Just say that is inflation rate, rate of inflation. We just say inflation rate of the country at the beginning of 2014. From 2014 minus 2006 is 8 years. If a t equals 0 is 2006, you add 8 is 2014. 2006 add 8 is 2014. So t equals 0, add 8. So t equals 8. So t equals 8 corresponding 2014. T equals 0 corresponding 2006. So inflation rate is the annual percentage rate of inflation. So we use R of t, represent rate, inflation rate, equal I prime of t over I of t. So we take I, which is I prime of t, over I of t. That's what we call relative rate, also relative rate of the change. And then you change to percentage. We call percentage rate of the change. If for the inflation, then we call inflation rate is equal I prime of t over I of t. So we take first derivative. I prime of t, take derivative is negative 0.4 times 3. Equals negative 1.2. And t to the power 3 minus 1 is 2. Plus 6 times 2 is 12. T to the power 2 minus 1 is t to the power 1. 100 take derivative is 0. Divided by I of t. I of t is this. And just copy done here. And the 2 divided. That's R of t, is the inflation rate. Then inflation rate. Then you do 8. T equal 8. T equal 8. Plug in. Plug in. Get 8 squared and plus 12 times 8. And this a cube. A squared plus 100. And this use calculator figure out 19.2. This use calculator figure out 279.2 and divided is 0.068 this. Change to percent. You move this decimal point to the right 2 position and round it up to here and round it. You got 6.88%. 6 round up. More than 5 round up. 7 add 1 is 6.88%. So this is annual percentage rate of inflation is 6.88%. If a time t, each t is t increased by 1 year, 1 year. Each time t increased by 1 year, then the inflation increased by 6.88%. Then show that inflation was moderating or slowing at the beginning of 2014. So we first of all we figure out second derivative. We got I prime of t is equal to negative 1.2 t squared plus 12t. Copy down over here. That's I prime of t. Take derivative again. I prime of t. Take derivative again. So the double derivative, second derivative. So it's negative 1.2 times 2 is negative 2.4. And 2 minus 1, so it's t. And the 12t take derivative is 12. That's the second derivative. And use 8 plug in t. And so get negative 2.4 times 8 plus 12. Then subtraction here is negative. So you got 7.2. Get 7.2. Negative is negative. Is less than 0. It's negative. So second derivative is negative. So then here say, we see that I prime is indeed I prime because the second derivative is negative. That means I prime is decrease. So I prime is indeed decreasing at t equal 8. So, and we conclude that inflation, the inflation, because I prime function at t equal 8, the rate is 6.88%. That's inflation is increase. Relative rate is increase. I prime of t is 19.2. It's positive, which is this consumer index is increase when I prime first derivative is positive. But second is, so this is inflation. Is go higher, price go higher each year, increase by 6.88%. Go higher and higher. That's the increase. Inflation is inflation. So the market is inflation, but take second derivative. That inflation, I prime of t, take derivative. You got negative. It's decreased. The inflation is decreasing. So we see that I prime is decreasing because take derivative is negative. So this one is decreasing. So take derivative is negative. Slope decrease. So I prime is decrease. So we conclude that inflation was moderate, slowing at the beginning of 2014. Inflation means inflation rate. If it is positive, that's inflation. If take derivative is negative, that's depression. Now it's inflation, but moderate because the second derivative is negative. Is the rate. So rate of the rate is decreased. So it's moderating, is slowing at the beginning of 2014. Slowing. Inflation is slowing. Question 6. A ball is thrown straight up into the air from the roof of building. Now here, the roof of the building is 140 in as is measured in feet, 140 feet high, the building. Because when t equals 0, the height of the ball as measured from the ground is given by s. This is the height of the ball. When t equals 0, is still on your hand, not throw out. The height of the ball is 140. So this person is on the top of the building, 140 above the ground, and throw the ball into the air, upward into the air. So t is how many seconds, and gradually go up and then fall down. So this is the building, and this building is 140 feet above the ground, and the person here throw the ball and go up and finally go down and touch the ground. So this height is when t equals 0, height above the ground is 140 feet when t equals 0, and throw out and go certain height, then fall down. So ask you, S is the measure in feet and t is seconds. Find the velocity of acceleration of the ball 4 seconds after it is thrown. Ask you the velocity and the acceleration, both, of the ball 4 seconds after it is thrown into the air. So velocity is the distance. Take first derivative is velocity, because velocity divide s prime of t is distance divided by time. You travel from here to there is distance divided by time. You travel how many time, and divided is how fast you go. So the speed is velocity, v of t equal first derivative s prime of t. So s prime of t, take derivative is negative 16 times 2 is negative 32t, and 64t, take derivative is plus 64. 140, take derivative is 0. So we got this. That's the velocity. When t equals 4 seconds, so 4 plug in t, get negative 62 times 4 plus 64. So this is negative 128 plus 64. So you got negative 64 feet per seconds. That's a negative direction. If go up, velocity is going to be positive, and you go down, direction go down, the velocity is negative. So negative, that means the velocity in here go down. After 4 seconds, the velocity is 4 seconds. The velocity direction is negative, so direction is downward. So the ball is falling downward at a speed of 64 feet per second. That means then velocity take derivative, we call acceleration. So this velocity is negative 32t plus 64. You take derivative, you got negative 32, and 64 take derivative is 0. So you got negative 32 feet, and then this velocity is per feet per second, and you divide it by second, becomes second square. This one, velocity divided by seconds, you got feet second square. So what this means the acceleration of the ball is 32 feet second square downward. Negative is downward at any time. Any time is constant, doesn't change with time. There's no t. So it's any time is always downward. Acceleration is 32 feet second square during the motion. Then next one, question 7. Question 7 is the implicit differentiation, and is section 6, 3.6. Implicit differentiation and the relative rates. The demand function for a certain make of inkjet cartridge is P equal negative 0.01 x squared minus 0.2 x plus 8, where P is the unit price in dollars, and X is the quantity demanded each week. X is the quantity demanded each week, measured in units of thousand. X is X thousand, and A, compute the elasticity of demand, which is this one, E of P equal net P times F prime of P over F of P. That's the elasticity of demand function in terms of P, price, each week. Because each week, this is the demand function each week, measured in units each week, and in dollars, and P is the unit price in dollars. X is each week demanded, measured in thousands. Compute the elasticity of demand and determine whether the demand is inelastic, unitary, or elastic when X equals 15. So elasticity formula is this. This one. So here we need to figure out when X equals 15, the price, how much we need to figure out. And also we need to figure out F prime RP, how much. FRP, how much. FRP is what? So we need to figure out F of P, which is X in terms of P. X in terms of P. So first of all, when we need to figure out the P, so then we use X given is 15, plug it in. So X is 15, plug in X, get 15 squared times negative 0.01 minus 0.2 times X. X is given 15, 15,000. X means 15,000 cartridge, inkjet cartridge. So figure out P, price, price per units. So 15